Hi everybody, Scott Stanchfield here. Let's talk about consuming RESTful web services in Android. But first of all, what is REST? REST stands for Representational State Transfer. And the concept here is that every object, every entity that you want to represent, whether it's a person or a house or something like that, each of them has a URI that uniquely identifies them. And that same URI should be identifying the same object each time you make a call to it. You interact with your web server, your REST server, using HTTP methods. Each of these methods has a specific meaning under REST, which we'll get to in a little bit. Here's an example of what these URIs might look like. If you have one that's like HTTP, some server and port, some path, ending in a type, that's considered a collection or a directory of information. And when you specify that, you're really talking about the entire collection at one point. If you add an ID on the end, you're referencing a specific item inside that collection or inside that directory. Now there are some unofficial extensions on this where you can actually add some parameters on the end. So if you wanted to have it do a search, you could say, let me look at the person collection and then choose the one whose name is Scott. That's not officially part of the original REST specification, but people use it quite frequently and it works pretty well. Each of these four HTTP methods represent one of the CRUD operations. So get represents your read, post represents create, put represents your update, and delete obviously represents your delete. So by using just these methods, you're telling what type of operation you want to perform against the server. You can return the data that's returned from these as JSON, XML, or some other format. JSON seems to be pretty popular right now. JSON has just about as much flexibility as XML, but XML can represent circular data structures and JSON can't. JSON stands for JavaScript Object Notation, and this is a data format that is actually JavaScript code representing a data structure. It is a strict tree, there's no cycles allowed inside of it, and you can see more information on it at json.org. We'll go through a couple quick examples, and it should be fairly obvious what this is doing after a little while. For example, if you have an object, this is an object representing Jenny with a phone number and an email, and the object is represented using curly braces. You have curly braces and then name value pairs separated by colons. Note that each of these names should be in quotes. Every once in a while you'll see JSON where they don't put the object name in quotes, and that usually will work. However, if there happens to be a variable called name and you're doing this inside JavaScript, it may actually evaluate the name variable and use that as the property name. So you really want to make sure these are quoted on both sides. A list of objects starts with a square bracket and ends with a square bracket, and then you have your objects with commas in between. You could also have lists of lists, you could have objects that have nested objects in them, and so on. But it's a fairly simple syntax to represent data being transferred across the web. On the server side, you could have any old implementation you want for this as long as it follows the right HTTP calls. So if you're doing the right CRUD operations for the right calls, it doesn't matter what you're implementing it as. In this example, I'm going to use Jersey, which makes it pretty easy to create a really simple REST server. We'll see in here that we can specify the path using this path annotation, and then for each function, we specify which HTTP method it's doing and what it consumes or produces as far as the media type coming in. So if we can accept JSON, if we can accept XML, things like that. And you could have multiple of these produces and consumes. It'll choose which to use based on the header being passed up when the client makes their call. So if the client has an accepts header being passed in, that accepts header will drive which media types will actually be used. And basically all these functions are going to do is do something to get your data and return it. That's about it. When you're using these REST front ends, try to keep it really, really thin. Now in the example code that I have, I don't have it thin. I actually have the REST controller doing all the work. He has all the data inside of him. Ideally, what you really want the controller to be is just to figure out what the input parameters are, call somebody else to do the work, and then take the data and marshal it out. So all he should be doing is understanding how to unmarshal and marshal the data. That's about it. And then which thing he calls. He shouldn't be doing any thinking. Don't follow my example if you're doing real life stuff. Try to keep the logic out of the controller. Again, this class isn't about doing server-side development, so I decided to try to keep this super, super simple. On the client side, you can use any HTTP library to access the data because you're just going to be making HTTP requests. In this particular case, I'm going to use retrofit2, which makes it pretty simple by annotating things again and annotating parameters. So here might be an example of the movie API service. You create it as an interface, annotate it with the get, put, delete, and update, and then define them just as functions, specifying what you're going to return. So if we take a look in the previous example here, this guy here is creating a response object that has a status and then the data inside of it. And that's nice because you basically are having two pieces of information together. The are we successful and the potential data coming back. In this case, we're going to say what's coming back is a response with a list of movies, response with a movie, and so on. And so this will take that response object and figure out the data inside of it. On the server side, when we create this response, this is actually going to set up the fields in the HTTP response coming back to the user. So it's not actually a special object coming back, he's actually setting things up. On the client side, this response object gets created to hold the header information from that response coming back. With retrofit, we then define a function inside the companion object of this interface to create an instance of it. So we just have retrofit builder, add any type of converter factors you want. In this case, we're going to use JSON to do the JSON to object conversion and vice versa. Where the server actually is, build it, and then create an instance of it. Boom. So this will set up the actual communication back to the server without us having to do a whole lot of thinking about it.